Okay, so the sketch shows Jim's walking route, and B is 2.8 meters from A, so that's 2.8 kilometers, not meters. And C is 6.2 kilometers from B, so that's 6.2 kilometers. And we've got to calculate the time Jim takes to walk from A to B to C and then straight back to A. So we want all this distance. That's this bit. We know two of them, so I need to find out this one. This one is not a right angle triangle, so I'm going to have to use either the sine rule or cosine rule. So I really need some angles. And the only angle I can work out is this one here. But I know that if I drop this down there, I've got that's 60, and this bit there must be 60. So this one here must be 120 because it's an angles in a straight line. And now 120 and 145, I can work out what the whole of this angle here. I've got 120, 145, that's 265. So this whole angle here must be 95 degrees. And I don't have a known pair. It's like I don't know this angle with this bit over here, don't know this angle with this one here, so therefore I'm going to have to use cosine rule, and that means it's A squared, so I'm going to call this one A, that length A, and I know that A squared equals, if I write it up here, A squared equals B squared plus C squared minus 2BC cos A. And so the A links with the angle associated it, so the A is going to link with 95, and it doesn't matter which one's B and which one's C, so I can just generally just write it straight down. So that'll be 2.8 squared plus 6.2 squared minus 2 times 2.8 times by 6.2 times by cos, which is 95, and that says that A squared equals 49.306047. And therefore A equals the square root of that, which is 7.0218. So now I know total distance. Total dist equals 7.02, just work it out, it's on 8, plus 2.8 plus 6.2, which equals 16.0218. Kilometers, but that's not what I wanted. I want to know how long, so I need to, well, I know its speed is, it says it's 5 kilometers per hour, so that's kilometers per hour using our triangle, and I want to know the time, so it's kilometers divided by speed, so it's going to be 16.018 divided by the speed, which is 5, which equals 3.20 hours. Now that's not 3 hours 20, that's certainly 3 hours, but 0.2 is 0.2 of an hour, so I would do 0.2 of 60. If you want to think of it, you could think of it as 2/10. 1/10 is 2, 2/10, 1/10 is 6, and therefore 2/10 must be 12. But if you do 0.2 of, so times 60, that will give you 12. The answer is 3 hours and 12 minutes. And state one assumption you made in part A. Well, I'll say he doesn't stop. He doesn't stop. That's why it's worthwhile reading, because you're going to get 1 mark for that. Or he walks in a straight line. But you should be able to pick up. He walks in a straight line. And explain how this affected your answer. In this case, I would say if he didn't walk in a straight line, it would take him longer. If he stopped, it would take longer. So 3 hours 12 is an underestimate, because he's likely to have taken longer, because he's likely to have stopped. And that's 18 done.